Yeah, good evening students. Today we will discuss about the number types in Python. So basically supports Python three types of number types: integer, float, complex number. So these are the three will comes under number type. Now first one we will see the integer. We all know the definition for the integer. So generally these integers are what it can be either 0, positive or negative whole numbers. So when you represent these integers, we will not consider the fractions into consideration, right? Now if you see the examples here, I have quoted a couple of examples: 0, 108 and 1099. These are the examples for the integers. Now how we can represent the integers in the Python means, let us go to the IDLE and we will see the couple of examples. Now see, let me take a variable a, then after I have taken 0, then let me take one more variable b, 23, and I have taken one more variable minus 89. Then after I am going to print all the three. See, these three were printed. Now I want to check what kind of data is holding by A, B, C, right? Using type function we can check what kind of data is holding by A, B, C. We can see the class of it. See, all are the integers. All are the what? Integers. Here I have taken different one. So positive or the negative whole numbers are the what? Integers. You can include the 0 also. You can include the what? 0 also. This is how you can represent the what? Integers in the Python. Integers in the Python. Now let's go to our presentation. Right now, these integers we can represent in binary format, octal format and hexadecimal format. Right now let us check it practically. Now take A equal to 0B 100. Let us check what exactly this A is holding. See, so if you want to represent the integers in the binary format, you must start with the prefix 0B. You must start with the prefix 0B. Then if 100, if you convert into decimal, then it is what? 4. Now let me take one more variable, b equal to 0b 1011. Let me print what is holding by b, 19. Now if you have a doubt, you can check what kind of variable it is, means you can check with the help of the type function. Type b. See, both are the integers. Both are the what? Integers. So yeah, that is what you have to understand. The integers can be represented in binary format, octal format and hexadecimal format. So you can also represent in what? Octal format, where the prefix is what? 0O. Then I will give 1 1. Then let me convert into what? Let me convert what is the value holding by A. See, it is 9. You convert that 1 1 into decimal, it is what? 9. Now let me take one more variable B. Yeah, we will take the new one. Yeah, we will save save it as octal, right? Now b equal to 0O34, then print b. Now let me execute this. Run module 28. Now if you want to check what kind of variable of b is, you can use the type function, then run it. Yeah, it is also a what? Integer. It is also a what? Integer. Now what is the another way of representing the integers? Means we can represent it in the hexadecimal format also, the where the prefix is what? 0x. Let me keep 1 1. Then after I am going to check what it is, the c. Then I want to check whether it is an integer or not using the type function. Using the type function. Now run module. Yes, that 1 1 is converted into what? Decimal. It is showing 17, right? And another important point you have to understand in the integers is, please remember, these integers should not have the fractional part. Even if you are trying to keep something, then it can be treated as a what? Float. Now you can check this. Type a, type b. You can run this program. A is an integer variable, b is a floating point variable. The moment you have added the precision, it will be converted into float. It will be converted into what? Float. That is what the difference you have to understand. Now generally in the mathematics, for example, if I want to represent some 10,115, this is how we can represent in the mathematics, but the same thing is not possible in the Python. If you see here, let us see how exactly it is interpreting. So I just want to store 10,115 under a, so for which I kept the comma. Now let's see how exactly it is treating. Yeah, it is treating like a what? A tuple. One is the 10, the another is the 15. Now if you want to represent a one longest number, instead of this comma in the Python, you can use the underscore. Thereby it can be what? 10,115. 10,115. If at all you want to represent a bigger number, yes, you can represent yes, you can see this. Run it. Yeah. Now if you have a doubt, you want to check it, yes, you can check it. Just print type a, right? Now if you run it, it is an integer. It is an integer. That is what you have to understand. Now you might have another question: what is the biggest number that you can store to an integer variable? That is also we will verify. Yes. Now I am just printing the a. Now let us execute it. See, right? Yeah, in this way you can represent the what? Integers. You can represent the what? Integers. Using the type function, what you can do, you can check what kind of data holding by a variable. That is what you can check with the help of the type function. Now you have to understand the another grammatical point in the Python. The leading zeros is not allowed in the Python. The leading zeros are not allowed in the Python. Let us understand it practically. Now I just want to assign a value on. See, left hand side, if you keep as many zeros, that doesn't make any difference in the mathematics. Now how exactly the Python is treating? See, actually a should hold the 1, right? Now see, leading zeros in decimal integer literals are not permitted. Use 0O prefix for the octal integers. This is what you have to understand. This is what you have to understand. Now what I am going to do is I just want to keep 0 1. Let me check it. Will it accept? No. So when you want to initialize 1, you make it as 1 only. Don't keep the 0 1. Don't keep the what? 0 1. That is what you have to understand. Now see this. Now if you see the rightmost digit, all are the zeros. Just now I told you leading zeros were not valid, but whereas it is valid when you want to represent the 0, see, it will take it as a 0 only. That is what the beautiness here. You have to understand. Now other than 0, if you are representing anything, it will not allow you. Definitely it will throw an error. Leading zeros in decimal integer literals are not permitted. Use 0 prefix for the octa integers. This is the important point you have to understood, right? So don't keep the leading zeros when you want to represent the non-zero value. Yes, if you want to represent the 0 value, you can keep as many zeros. The system will take in it as a what? 0 only. This is the problem. The leading zeros problem will be there for what? Non-zero values. Non-zero values. This is the important point you have to understand. Now this is what Python doesn't allow the comma. When you want to use some delimiter in order to improve the understandability and readability of the number, then instead of the comma, Python permits the what? Underscore. This underscore can be used as a what? Delimiter for the number, but don't use the comma, just what we did in our mathematics, right? And remember another important point I already told you, when you are talking about the integers means don't bring the precision into precision or the dot into the point. If you, the moment you added the dot in the number representation, immediately it will take it as a what? Floating point number. Immediately it will take it as a what? Floating point number. So the next thing you have to understand as far as this integer is concerned, you have to talk about the conversion function int. So this conversion function, yeah, now int, let me take 3 variables, a, b, c. So in the first variable I am going to store 1, 2, 3. In the second variable I am going to store 3.4. In the third variable I am going to store some 5. Now what I am going to do is I am just going to convert into what? The integers. Let me take 3 more variables, c, d, e. Then here I am going to write int a comma int b comma int c, right? Then after I am going to print c, d, e. Then I am also checking what kind of data is holding by c, d, e. Type c, type d, type e, right? Now run it. See, all are integers. All are integers. So using this conversion function, what you can do is you can convert a string into integer. You can convert a float into integer, right? Even if it is already in an integer format, there is no meaning of using the conversion function, that is what? Int. Now what if something it is there in the alphanumerical, how exactly it is acting? That is what we are going to check now. A equal to, let us say 1, 2, 3 D, E, F. Then after you just converted this A into integer type. See, A is a what? Alphanumeric. Now let us check it. Value error. This is what you have to understand. Now 1, 2, 3 is consists of the what? Some alphanumerical alphabets are there. Alphabets cannot be converted into what? Integer. Alphabets cannot be converted into what? Integer. You can try like this also, right? Now see, value error. So when you want to convert the string into an integer, remember within the double quotes it must have the decimal values only, it must have the numbers only. If it is combination of alphabets and the numbers, it cannot be converted into what? Integer. Now a equal to int 100 comma, let us say 16, then print a. Now let us check what can be happen. Cannot convert the non-string with explicit base. Okay, understood. Now let me pass it as a what? String. Then I just want to convert into what? Hexadecimal. This is an hexadecimal value. 100 means what? 256. Similarly, you can do it for what? Binary also. Now 4 will come. So the second argument will indicate the what? Base. Now similarly you can pass the 8 here. Right. 64. So this is what the integer conversion function. Now the next one we are going to see is the float. Now the float means, which you already know, the moment if you have the dot in the number representation, it is a what? Floating point. You can check with the help of the type function, right? This is what. Now the another important thing you have to understand, you can represent the floating point value in scientific notation also. B equal to 3e2, then let us print B. This E can be capital R, small, not an issue. See, now what will come? 300. So the exponentiation, it will be technically it is what? 3 into 10 power 2. 3 into 10 power 2. Now let us say 3e or 2.5. Let's check it. Yeah, this is what you have to understand. Whatever the value you have mentioned after the E, it must be what? Integer value. Do not keep the floating point number. Whereas here you can keep the decimal. For the mantissa you can keep the what? Decimal. See, that is what you have to understand. For exponent component, don't keep the what? Decimal value. Right? Now similarly you can have as many E. Then I am going to keep -5. Let us see what's going to be happen. Will it accept the negative numbers or not? Yes. Right? Now, then what I am going to do is 2 power e 800. Let's check. Yes, there is a limitation you have to understand here. 2 power, what we are doing? So this is what? 2 into 10 power 800. That is the biggest number. It cannot accommodate. That's why it came it as a what? Infinity. It came it as a what? Infinity. And using the another thing you have to understand, this using the float function you can convert the string or the integer into float. Yeah, that is what we can confirm it now. Float. You can start with the double quotes 12.3, then b equal to float some 3 I want to convert. Now print a comma b, then print type a comma type b. Now let us execute this. So if you execute this, see here. So 12.3 and 3.0. 3.0. This is what about floating point number. Floating point number. The next is the complex number in Python. Complex number, it will have the two components. One is what? Integer component. The another is the imaginary component. The imaginary component you can represent with the help of the small j or the capital J. Small j or the what? Capital J. Absolutely no issue. Print a comma b. So if you want to check what kind of data is holding by the variable, you can use the what? Type function. So using the type function you can check whether it is the complex number or not. Yes, it is showing both are the what? Complex numbers. Both are the what? Complex numbers. And this is not the only way. You can also use the what? Complex. Some 2 comma 3 using the complex function also you can have the what? Complex numbers. Right? So generally on the integers or the floating point numbers we can perform the what? Arithmetic operations. Similarly on the complex numbers also you can perform the what? Arithmetic operations. So whatever the arithmetic operations you want to perform, yes, you can perform it. Now see here, I am performing addition, subtraction, division, multiplication. See, all will happen. Right? Even if you want to use some exponential operator also, yes, you can use. Exponential operator also you can use. Similarly, if you want to use the remainder also you can use. And similarly, if you want to use some floor division also you can use. See all these. So whatever the arithmetic operations we are performing on it, we can perform. But remember here, the unsupported operation for the complex number, that is what? Mod is not accepting. Mod is not accepting. Mod is what? Not accepting. Okay, let us remove this mod. Then execute this program. So modulo is not accepting for the complex number. Similarly, it what? Floor division is also not accepting. Right. Now save it. So this is what the Python numbers int, float, complex number. In the next class we will discuss about the next topic.